Okay, thank you very much for kind introduction. So my name is Masaki Takaoka. I'm a professor in Department of Environment Engineering, Kyoto University. I'm very honored to have a presentation in this symposium. So I really appreciate that opportunity and say thanks to that organizing committee, especially that the Professor Seo. Okay. But I'm sorry, I cannot make it over there. So I would like to speak via online. Okay. So today's topics are the current situation of waste to energy and towards carbon neutrality in material cycles and waste management in Japan. So today's content is here. The first part, I would like to explain that Japanese situation on the waste treatment in Japan. And also, I would like to introduce that the waste to energy situation. And the later part, so I would like to talk about that the carbon neutrality in waste sector in Japan. So last year, so Ministry of Environment Japan proposed that the future scenario and estimation toward the carbon neutrality in this sector. So today I would like to introduce that proposal, I think. And recently, so we already started the challenge of that waste energy with CCU, etc. So I would like to introduce that case studies. Okay, so we would like to move to that first part, the waste treatment in Japan. So the amount of the waste, municipal solid waste, gradually decreasing from 2000 to 2020. At present, almost 40 million tons of waste is generated. So incineration part, that's the orange part, is almost 80%, and the direct landfilling, so that black part, so that is just only 0.9%. So recycling is almost 20%. So we have to enhance the more recycling, I think. Anyway, so waste to energy, so incineration is very popular in Japan. So waste to energy facility can provide various values in the local area. So as you know, so traditionally valued hygienic treatment and volume reduction, and also energy recovery and supply. So recently, so that role has been expanding. So for example, so we have many natural disasters, such as a typhoon and earthquake and etc. So we need the disaster prevention based in the local government. So that waste energy facility also has that role. Okay? And also that waste energy facility can accept that other waste in the local area, such as other biomass waste and etc. And also that construction of the waste energy facility contribute that the local economy. And also, waste energy facility regarded as a environmental education base. So today, main part is waste energy, I think. So I would like to talk about that current situation of that waste to energy in Japan. Okay. This slide shows that waste power generation. So that waste power generation is increasing and increasing. So nowadays, the power generation amount is exceeded 10,000 gigawatt hour per year. And also, power generation efficiency reached to that 14%. Not so high, but so anyway, recently we constructed that waste energy facility with the high power generation efficiency. So that index has improved and improved. Today, I would like to introduce one example. So it is an incineration facility in the Hatsukaichi city. So that incineration facility, that blue dot line, so that is a incineration facility. That scale is not so big, so 150 tons per day. But that incineration facility produce that electricity and so heat. So electricity generation efficiency is at 21.6%. And also that facility supply the heat to the neighbor facility, neighbor factories. So that factory use that so heat to vaporize that liquid natural gas. So maximum energy efficiency reached almost 70%. So CO2 emission reduction is estimated as follows. So reduction by heat supply is 5,400 tons per year. And the reduction by the power generation is also estimated to be 4,300 tons per year. Totally almost 10,000 tons per year. So that amount is almost equivalent to the annual emission from 1,800 households in this area. Also, it is more than expected reduction in the industry in these cities. So that table indicates the annual revenue of electricity and heat supply. So this is so attractive for the local government, I think. Okay, so this slide shows that other waste energy technologies for the municipal solid waste in Japan. So Dr. Bauer said that the fermentation technology also that is one of the waste energy technologies. In Japan, so this blue line, that is a biogas plant capacity, not so big at present, but so recently, so many local government are concerned that biogas plant. So that orange part bar graph indicates production of the RDF, refuse-derived fuel, and refuse plastic and paper fuels. That capacity almost 3,000 tons per day and etc. So RPF from the industrial waste almost 1.54 million tons. So that capacity is not so big compared to that RPF from the industrial waste. So anyway, in Japan, the waste to energy, the incineration is very popular. But recently, the combined system of incineration and biogas has also been introduced in some cities. The construction cost of the combined system is a little bit higher than that of the only incineration plant. But that combination system has various advantages and is effective for the CO2 emission reduction and energy efficiency. So recently, so large cities such as Kagoshima, Kyoto, and Machida City choose that system. Okay, so from now, I would like to switch to that next topics toward carbon neutrality in Japan. So it is urgent need to tackle the climate change measures. Almost 2 years ago, so late Prime Minister Yoshihide Suga pledged a cut in the greenhouse gas emission in Japan to net zero by 2050 in his first policy speech. In original plan on global warming prevention plan, Japan will achieve the 26% reduction by 2030 and 80% reduction by 2050. But the government changed that target value to that 46% reduction by 2030 and net zero by 2050. So based on that policy change, the Ministry of the Environment Japan proposed that mid and long-term scenario toward carbon neutrality in waste sector in last year. So firstly, I would like to talk about the GHG emission in waste sector in Japan. So this is a greenhouse gas emission. So that greenhouse emission is based on that IPCC rule. So landfilling and biological treatment, incineration, use as fuel, wastewater treatment, and others. So as you can see, that incineration and use as fuel occupied almost more than 80%. And this slide indicates that CO2 emission in waste incineration and use as a fuel. So that graph indicates that about almost 80% of that contribution are the waste plastics and waste oil. And that graph indicates that the trend of the waste plastic and waste oil. So, as you know, that so plastic is a key material to achieve net zero. So furthermore, so in response to that waste plastic issue, including the plastic marine debris and export ban, so recently the resource circulation policy for the plastics in Japan has been decided and implemented. So we have discussed that countermeasure toward carbon neutrality in these sectors. So as you know, that the 3R in this sector is very popular. So we add one concept, so that renewable. It means we need switching from that fossil fuel-based material to that bio-based material. It is essential, I think. So that key area is the waste plastic and waste oil. One example, so maybe so in the near future, so we produce that so bioplastic and etc. Okay. And the second is also we need the more GHG reduction in the waste treatment. So energy recovery from that waste is more promoted, and carbon capture will be necessary to achieve net zero in this sector. And the third, appropriate disposal. Also, that is an essential, basic demand in the waste sector. So more energy saving in the facility are necessary, and also collection vehicle will change from that engine to that EV. In the operation, renewable energy should be used. So that's why I showed that basic concept of the net zero in waste sector. So at present, so we produce the GHG. So But so in the near future, so GHG emission will be reduced by the reduce and reuse and material recycle and the chemical recycling and the switching from that fossil-based material to that bio-based materials and etc. But GHG emission in waste sector will remain in the future, I think. On the other hand, so in the IPCC rule, under the IPCC rule, so GHG reduction is not estimated from that waste to energy, I think. So if we achieve that net zero in this sector, so we have to use that so CCUS technology, I think. Oh, okay, I forgot one important point. And because so nowadays, so we can evaluate that so we can evaluate the electricity generated from that waste energy at present and also in the 2030, I think. But if that energy source, electricity source completely change to that renewable energy, so we cannot evaluate that electricity generated from that waste energy, I think. So we need that the CCUS in this sector. Okay, so this table that indicate that the GHG reduction scenario in that waste sector and also estimation. So first scenario is a BAU, and so second to seven scenario, so we consider that future waste generation and composition and recycling and treatment to achieve net zero in waste sectors. So the scenario also harmonized with that existing policy. So for example, that's plastic strategy and global warming prevention and etc. Today, time is limited. I can't say the detail of that each scenario, but anyway, we enhance that restriction and also we developed more and more technology and etc. We can reduce that GHG emission. But even if so we apply that extended innovation scenario, so 6.2 million of GHG emission will remain. So if we achieve that net zero, we have to use that CCUS. The timeline of the introduction of the countermeasures. So at present here, so that one scenario is a business as usual, and so 2 to 7 is here. So by 2030, so it is difficult to apply the new technology and new scenario and etc. So that is the same line. But after that, so we assume that different scenario and etc. So anyway, so the scenario 6, so net zero will be achieved in the 2050s. So from now, I would like introduce some trials in Japan. So in Saga City's CCU plant has been already introduced in the initiation plant from 2016. Capacity the 300 ton per day of that waste is treated in the stoker type incineration plant, and just 10 ton days CO2 is recovered. And that CO2 supplied to that neighbor agriculture farm. So alga cultured, and hydroponic cultured, and so vegetable cultured, etc. So if CO2 used in the agriculture site, because the farmer would like to earn that heat and the CO2, so incineration facility become a welcome facility and disappear the NIMBY problem. So next is a project and the methanation from the CO2 from municipal solid waste incineration flue gas. That project demonstration production the methane on the commercial scale by reacting CO2 with the hydrogen. Through the demonstration, the challenge for the diffusion of the methanation technology will be clarified. And the effectiveness of the technology in reducing CO2 emission will be also examined. Another case study is methanol synthesis from the CO2 from the MSWI flue gas. So methanol was produced from captured CO2 in the MSWI flue gas in the Clean Plaza Fujimi Center. So methanol conversion test conducted at laboratory of the Mitsubishi Gas Chemical Company. And last, that is a ethanol synthesis from municipal solid waste gasified flue gas. So combustible waste gasified at a rate of the 20 tons per day in the Kuji cities. This gas is purified and converted in the methanol using that microorganism developed by the Nanotech, a US company. Furthermore, in collaboration with the Sumitomo Chemicals, the project constructing the loop to convert the ethanol into the ethylene and then into the plastics. So last, that is the conclusion. So time is very limited, so I would like to skip that conclusion. Okay, so I'd like to finish my presentation. Thank you very much for your kind attention.